Alright, we are now on page 3, so I'm going to start with number 20. And so, number 20, we know that the original graph of a y equals absolute value of x is just a v that looks like this. But this particular graph is going to be shaded or shifted, the vertex shifted 1 unit to the right and 2 units down. So the vertex is going to be here. And there is no a value up here. It's not going to be shifted. It's not going to be stretched, and it's not going to be flipped over the x-axis or flipped upside down. It's going to open up, but it isn't equal to this. It does say y is greater than that. So my v is going to be a dotted line that looks like this, just shifted, and I want the y values that are greater than that, which means I'm going to shade above this v. And so all of these points here are going to be part of my solution set. Not the line itself, because that's a dotted line, just the area above it. That's number 20. Number 21. So the polynomial equation with rational coefficients has roots 2 minus the square root of 2 and 4 plus the square root of 5. Find two additional roots. Well, we know that if a rational solution looks like this, its conjugate is also going to be a solution. So 2 plus radical 2 is going to be a solution, and so is 4 minus radical 5. Those are both going to be solutions. For number 22, it says for the equation that find the total number of roots. Well, it's a 6-degree polynomial. So the total number of roots is 6. So it has 6 roots, 6 complex roots. The possible number of real roots and the possible number of imaginary roots. Well, of those 6 roots, they're either going to be imaginary or they're going to be real. Imaginary ones come in pairs, so I could have 0 imaginary ones. I can't have 1, because if I have 1, I automatically have 2. So I could have 2, I could have 4, I could have 6. I can't have 8 because there's only 6 roots altogether. If there are 0 imaginary ones, that means all 6 would be real. If 2 of them are imaginary, 4 would be real. If 4 are imaginary, 2 would be real. And if all 6 are imaginary, 0 would be real. And so the possible number of real roots are 6, 4, 2, or 0, and the possible number of imaginary roots are 0, 2, 4, or 6. Take a look at 23. 23, it's going to be really important for you to have to know this is the sum or the difference of 2 cubes. We should know that if I have the difference of 2 cubes, that's a cubed minus b cubed. There's going to be a small factor and there's going to be a big factor. The small factor is just a minus b, and the big factor is going to be a squared. The last term is going to be b squared, and the middle term is going to be a times b. If this is a minus, that's a plus, and this is always a plus. So if I'm going to factor this, the small factor here is just going to be x minus 4, because x cubed is x cubed, and 4 cubed is 64. 4 times 4 is 16 times 4 is 64. That's my little factor. My big factor is going to be x squared. I'm going to take 4 squared, which is 16. That's my last term. And I'm going to take x times 4, which is 4x. And if that's a minus, that's a plus. So that's how I would factor this. Well, then I could actually solve this, because if this times this is equal to 0, either this is 0, which means x is 4, that's one solution, or this whole thing is equal to 0. Now I can't factor that. So I have choices. I could complete the square, or I could use the quadratic formula. Most people would probably use the quadratic formula. That's negative b, which is negative 4, plus or minus the square root of b squared, which is 4 squared, or 16, minus 4 times a, which is 1, times c, which is 16, all over 2 times a, which is 2 times 1, or 2. So I'm just going to go over here and try to figure out what this is. This is 16 minus 4 times 1 is 4, and 4 times 16 is 64. Well, 16 minus 64 is negative 48. Well, I can simplify that, because 48 is 16 times 3 times negative 1. So it's the square root of 16 times the square root of 3 times the square root of negative 1. Well, that's 4i radical 3. So if I put that back in up here, this is going to be negative 4 plus or minus 4i radical 3 all over 2. That's what x is equal to, but that can be simplified. because this 2 can divide both of these 4's. I can have negative 4 over 2, which is negative 2, plus or minus 4 over 2 is 2I radical 3. And my three solutions are x equals 4 and x equals negative 2 plus or minus 2I radical 3. Let's take a look at number 24. All I want to do here is factor this. This looks like it's going to be a special quartic equation that can be factored like this. I want something here and here that multiplies to give me x to the fourth. That's going to be x squared times x squared. Then I want something here and here that multiplies together to give me 16 but adds to negative 15. So how about a negative 16 and a positive 1? That would give me negative 16x squared plus 1x squared, which is negative 15x squared. Well, then I could factor this further. The x squared minus 16, that's going to be x plus 4 times x minus 4. Because 4x and negative 4x, that gives me nothing in the middle. I can't factor this anymore. I could if it was x squared minus 1, but I can't factor it anymore if it's x squared plus 1. So that just has to stay x squared plus 1. And factored completely, it would be x plus 4 times x minus 4 times x squared plus 1. Let's move on to number 25. Again, we're factoring, and so I'm going to see if I would look at first to see if there's anything that goes in 9, 17, and 2, and there isn't. So then I'm going to try to find something here and here that multiplies together to give me a 9x squared. 3 and 3 would work. But I don't think in this case that it actually does. I'm going to try 9x and x, because 9x times x gives me 9x squared. And then I want something here and here that multiplies together to give me a negative 2. I'm guessing if I put a 1 here and a 2 here, and if I make this negative here and this positive here, my inside terms would give me a positive 1x. My outside terms would give me a negative 18x, and a 1 minus 18 is negative 17. So this factor is just 9x plus 1 times x minus 2. Number 26. I'm going to solve this equation for x. So now this is a quadratic equation. There's 5 different methods. We talked about how to do this in class. One way is to graph it. We could certainly get our graphing calculators and try it that way. I can't use square rooting because I have an x squared and an x. I might try to factor it. Maybe factoring it works, but if I do factoring, I have to make it equal to 0, which means I'd have to write it like this. X squared minus 11x plus 30 equals 0. Let's just see. X times x would give me x squared, and I want something that multiplies together to give me 30 that adds to negative 11. Well, how about negative 6 and negative 5? That would be negative 6x and negative 5x, which is negative 11x, which works. And if this times this is equal to 0, that means x is either equal to 6 or x is equal to 5. Take a look at 27. Find the domain and the range of the graph. Well, the domain is how far back and forth does it go. That's the x values. Well, it goes forever this direction. Now, it's going to be really high, and it goes forever to the left. That means the domain values, it goes from negative infinity to positive infinity if I write it in interval notation. Okay, or I could just say x equals all real numbers. On a multiple choice test, you should know both ways to say it, though. And then this is the domain. Then the range is the y values. How far up and down does it go? Well, it goes up forever, but it only goes down to 2. So it goes from 2 to infinity, and it includes 2. So I'd have a bracket there. Or I could say it's this, y is greater than or equal to 2. You should know both methods. This is interval notation, these two, and this is just as inequalities. Let's move on. Take a look at 28. We want to factor this completely. So I'm going to look first to see what goes into all 3 terms. It looks like 4x does. And then I'm going to multiply 4x times 3 things that gives me these 3 things. The first thing would be just x squared, because 4x times x squared gives me 4x to the third. The second thing is going to be 4x, because 4 times 4 is 16, and x times x is x squared. Then I want something that I can take 4 and multiply it by to give me 128. Well, I think that's 32, negative 32. 4 times negative 32 is negative 128x, and I have the x here. So far I factored out a common term. Now I wonder if this can be factored any further. I already have the 4x on the outside. So now I'm going to see if I can put something here in these two parentheses to make it equal this trinomial. This would have to be an x times an x because that gives me x squared. Then I want something that multiplies together to give me negative 32 that adds to positive 4. Well, how about an 8 and a negative 4? 8 times negative 4 is negative 32. This is 8x minus 4x, which is 4x. So factored completely would be this. Now, number 29 is a little bit different because it doesn't want me to just factor it. It wants me to solve it. But I'm going to try to solve this first by factoring. I don't know if I can or not, but let's just try this out. I'm going to guess that this is going to be a 2x and a 2x to give me 4x squared. Then I want something here and here that multiplies together to give me 15, but somehow my inside terms would give me 7. 5 and 3 would work. At least it would give me 15, but 5 times 2 is 10, and 3 times 2 is give me 6. That's not going to give me 7. I could try 15, but that's going to give me 30. I don't think that's going to work. Maybe it would have worked if I would have had a 4x and an x. Then I could have had a 3 and a 5. That might work. If I put a 3 here and a 5 here, let's make this one negative and this one positive. Let's just try this out. This would be 5x. This would be negative 12x, and 5x minus 12x does give me negative 7x in the middle. So it is factorable. And so then I have two things that multiply together to give me 0, which means either the 4x plus 5 is 0, or the x minus 3 is 0. Well, if x minus 3 is 0, one solution is x is 3. If it's this one, I would subtract 5, and then I would divide by 4. So x equals negative 5/4. And my two solutions are 3 and negative 5/4. Could I have done that by graphing it? Absolutely. And you could do that on your test as well. Take a look at number 13. Which of the following is not a linear factor of this polynomial function? Well, I could graph these. Let me just show you how you could do this by graphing it. I'm going to go back to my window and make it the normal window from negative 10. I don't know why I always mess that up first. I'm going to go from negative 10 to 10, and I'm going to count by ones, make this negative 10 to 10, and count by ones. So if I just go to my y equals and type this equation in there, this is going to be x to the third power minus 3x squared minus 4x and then plus 12. I'm going to graph that. Wonder where it's going to cross the x-axis. Looks like negative 2, positive 2, and positive 3. Negative 2, positive 2, and positive 3. If that's the case, then x plus 2 would be a factor, x minus 2 would be a factor, and x minus 3 would be a factor. It says which of these is not a factor. Well, x plus 2, that one is. X minus 3, that one is. X minus 2, that one is. C is my answer. That's not a factor. And I could test that out, because if I were to do synthetic division and I tried a negative 3 here, because that would be my solution, I'm not going to get a remainder of 0. This is going to be 1 times negative 3 is negative 3. If I add those together, that's negative 6 times negative 3 is 18. 18 and a negative 4 gives me positive 14 times negative 3. Boy, it's 42, I think. Negative 42. If I add those together, that's negative 30. That doesn't give me a remainder of 0. That's not a solution. That's the third page, everybody. Hopefully that made sense. If not, you can ask me questions in class tomorrow.